Function works like this. I'm going to take this line right here. This is the equation of the line, which is y equals x. What I want to do is I want to graph f of x. Sorry, I know the notation looks all confusing, but I don't really need that. I want that. Now I write it like that because I want to make sure that you understand that you're taking 1 over all of the y values. Okay? So there's a real slick and easy process to what happens here. So you have to follow the process in order to do it. So the first thing I do is graph my original line, which again is y equals x. The second step in this, if I'm taking 1 over, well, let's put this down just a second. Let me put down just a few numbers. So that's what a table of values for y equals x looks like, right? Now if I want to take the reciprocal of this, meaning I want to take 1 over all of my y values, okay? The first thing that we have to identify is where y is equal to 0. Because if I take 1 over 0, what do I get? It's an undefined value, but when I take 1 over 0 on a graph, I get an asymptote. So where on this graph here does y equal 0? Where it crosses the x-axis, that's right. So that is right here. So what I do first is I draw my vertical asymptote in there. So that's the first thing that you do after you graph the original graph. So you graph your original, and then the second thing I do is put my asymptote in. Now this is an important process for next year, because this is one of 5 graphs that we have to know very well, because they're expected of you, and then you got to be able to shift these without any hesitation next year. So I've got 1 over 0 as the asymptote. The third thing that I identify is where y equals plus minus 1. Because what's 1 over 1? 1. So this coordinate right here, and this coordinate right here, those aren't going to change. They're still going to be 1 and 1, and negative 1 and negative 1 on my new graph. Okay? Now, I want you to do some thinking now. The y values. So this is y equals 1 here, and this is y equals 0 right here, right? What do I find? What kind of values do I find between 0 and 1? Decimals and fractions, right? Bless you. Okay, so let's take the fraction of 1/2. When I take 1 over 1/2, what does that equal? No. 1 over 1/2. 2. Okay. When I take 1 over 1/3, what does that equal? 3. And 1 over 1/4, what does that equal? 4. And 1 over 1/5? 5. 1 over 1/6? So for all of these values right here, all of these fraction values, what's happening to them when I take 1 over them? No, they become whole numbers, right? And they become larger. So this new graph is going to go up like this. The same thing happens between 0 and negative 1 because all of these are fractions down here. So my graph goes like that. Okay? Now, as I move away this way, okay, as my x gets larger, these values are getting higher. So when I take 1 over them, what happens to them? They become what? Well, this is 2 right here, right? What's 1 over 2? Half. What's 1 over 3? And 1 over 4? 1/4. So what's happening to those, as I move further this way, what's happening to those values? They're getting smaller. And they're going to get smaller and smaller, and they're going to approach this line, but never cross it. Why? Well, as my values move towards infinity, they get smaller and smaller and smaller, but you can never take 1 over a value and end up with 0, can you? So they're never going to hit that. The same thing hits right here. So the last thing that we do with the reciprocal function is we shape our graph. Now in theory, this is also considered an asymptote. An important one as well that we use for next year. Okay? So you have two asymptotes. The equation of asymptote number 1, this guy, x equals 0. The equation of this asymptote right here is y equals 0. Those are the equations of my asymptotes. Okay, so far? All right, these 4 steps right here. Now, as we go into grade 12, you're going to be able to just sketch this quickly without, when I say reciprocal, 1 over x, you just sketch it, just like that. Here, here, asymptotes, asymptotes, done. It's that simple. And then we have, but it's one that we have to know. Okay? All right, so let's move on, and let's look at our first example in our book. It says, sketch the graph of y equals f of x, and then it's reciprocal of 1 over f of x, where f of x is equal to 2x. Okay, so the first thing that I do is graph y equals 2x. All right? So how do you graph y equals 2x? What's my y-intercept? 0. That's where it crosses. Right here. And then what does my slope tell me to do?
2 up, 1 right.
2 up, 1 right. Just like that. Okay? So there's my original graph. Now you could fill in your coordinates if you want it on there. I'm not really too concerned. You got -6, -4, -2, -1, -1/2, -1/3, 0. You could go through all of that. And you could fill those in. Okay? So, I've done my original. What's the second thing that I'm supposed to do now? According to those 4 steps, what's next? My asymptote. And where does it cross the x-axis? Right there. So that becomes an asymptote right there. Just like that. Because I'm taking the reciprocals, where does y equal 0? Along this axis here, right here, right? Okay?
So like say if it was,
We'll worry about, we're going to get into where it changes. Okay? For right now, let's just worry about this guy. Alright, so what's the next thing? It's the third step.
y is equal to
Plus minus 1. So that's right here. That's right here. And then I shape my graph. And I'm done. I gotta add in this asymptote and that's it. That's it.
Do you have to go with x equals 0?
It may ask you for what the equation of your asymptotes are, so yes. You would say x is equal to 0, y is equal to 0.
If it was more over, it'd be like
Well,
x
we're going to get to a more over graph. That was the same thing he just asked too. We'll do that next. Okay? Are we okay? Any questions? 4 steps. 4 steps. If you can't graph a line, then this is not the class for you. You've got to be able to graph a line. Okay. Next one. Example 2. Y equals 2x plus 1. Y equals 2x plus 1. What is my y-intercept?
1.
1. So right there. Okay? And where do I go from 1?
2 right.
2 up, 1 right. Here, there's the equation of y equals 2x plus 1. It's the first thing that I put in there,
Your answer.
my asymptote. And where does it occur? mark off where it's y equals 1, right here, and y equals -1, right here, and shape it. So it curves towards those two lines, but it never crosses them, and it never becomes a straight line.
So just like keep on getting rid of those?
Yeah.
Will the x asymptote ever change? Like will that one?
It could, you'll see after, if the equation, yeah, it will change. Okay? All right. Just take a look at the working example 2, please. What is the reciprocal function of f of x? Well, that's 1 over 2x plus 1. Determine the equation of the vertical asymptote. The vertical asymptote in this case ends up being,
Y,
no,
y equals -1.
no,
Y equals -1.
this is it, okay? The vertical asymptote here. This is your y equals, right?
Oh,
My new graph is y equals 1 over 2x plus 1. My vertical asymptote will always be the non-permissible value.
so what?
What is it though?
X is not equal to.
Well, because you don't write not in this case, because that's the equation line. X is equal to -1/2. That is my vertical asymptote. It is also my non-permissible value there. So that's an easy way to figure that out. Okay? And C, what did C say? Graph the function, I already did. Okay? Questions? 4 steps, what are they?
Graph a line.
Graph the
equation.
original. Second,
Asymptote.
asymptotes, where do they occur?
The x-intercept.
Yeah, good. Well said. Where the x-intercepts are, where it crosses the x-axis. Good. Then, y is equal to plus or minus 1 because 1 over those values stays the same. Those are the only coordinates you actually need in the graph. Those are the only coordinates you actually need on the graph. Okay? And then the last step is to draw your shape, which is just your two curves. Okay? Yeah.
If you put that equation like y equals 1 over 2x plus 1 into Desmos, would it do that for you?
Yes. Yeah. You will be able to use Desmos today to check your graphs. Okay, the last one I'm going to show you is the one that's the most complicated. F of x is equal to x squared minus 1. Okay, so first things first, we need to sketch that graph. What is the vertex of this graph?
-1 and 1.
No. Vertex.
Oh,
What is it?
1 and
0
0.
and what?
-1.
Yes.
Oh, whoops.
0, -1.
Yeah,
H, K.
yeah.
So I've got 0, -1. What are my intercepts?
-1 plus 1.
-1 plus 1. Very good. So I'm going to graph my original. Like that. And like that. So this is important to follow as we go here. You need these steps to do this. Okay, so there's my original graph. Again, my expectations are you can graph a parabola in vertex form quickly. You need to be able to do that. Okay? These are the types of things that you're going to be tested on next year. So you have to be able to do these simple graphs as quickly as you can. All right, what's the next thing?
Your thingies.
Asymptotes. And where do they occur?
X-intercept.
X-intercepts. So let's mark those in. So how many do I have today?
2.
I have 2 on this graph. Just like that. Good. Okay. Now what?
Figure plus minus 1.
Plus minus 1. There's plus 1. There's plus 1. There's minus 1. Okay?
Okay, how did you get that?
Where does the graph, where does my red lines cross y equals 1 and y equals negative 1? That's plus 1 right there. So that's where it crosses. Because when I take 1 over it, I end up with the same thing.
Yeah.
Okay, now, to shape this graph, all the values from here to here are going to get what? All the values from here to here are going to get larger or smaller.
Smaller.
Larger.
I'm taking 1 over all of these values.
Oh, yeah.
And they're all fractions. So when I take 1 over them, do they get larger or smaller? Larger. So this is going to go up like this. What about these big numbers? Do they get larger or smaller? Smaller. That seems to be the most difficult thing for people to understand. I still see some blank faces, so let's talk about this. This red line goes from here to here. What are my y values from here to here? They're all fractions, or decimals, correct? From 0 to 1, there's 0.5, 0.25, 0.6, 0.9, whatever, right? So when I take 1 over them, 1 over a half is 2, 1 over a third is 3. So just think of it like that. Therefore, this section of the graph goes up. And these values that are greater than 1 all become fractions. The graph goes down like this. Again, this is one of my horizontal asymptotes, but I'm not done. Here's the part that you haven't seen. This is different than a line. When I go 1 over negative 1, what do I get? Negative 1. Simple, right? These are all fractions again. So the new graph goes like this. Just a little miniature upside down problem. The blue on that board right now is the graph of one over x squared minus 1. Okay? Yes, sir.
Will it ever, like on the top there, when they're going up, they'll never cross that asymptote, right?
No. They always approach the asymptotes, but they never cross them. Ever.
And on the bottom, you know how it goes down?
Yes.
There's nothing that goes up there.
At this point?
Like,
No.
you know on the top how there's going down and then
Mhm.
going up, not the same on the bottom?
Sorry?
There's not the same on the bottom, going up and going down. No. That makes any sense.
Not really.
Like it won't, like the little miniature parabola, that
They
won't
can
be
go up
flipped
here. Oh, like, or up here. Which part are you talking about? Like,
I'm talking, like, you
Like
know
if
on
the
the,
graphs would be positive, the A values are positive, it would open up.
we don't switch them. No. You're just taking 1 over all of these coordinates down here.
I guess, yeah, because that stops at 1, right?
Yes.
Okay, yeah. It never gets above that, so.
Right. Okay? Alright, that takes care of reciprocal functions. So what you should do is probably spend a little bit of time going through that. I haven't done the hard part, which is the 4th example, but I'll do that on Monday. Tuesday, sure, then Tuesday. Okay? So you may want to look at, if I was to make a suggestion right now, I would do 318 and 319 right now. And then go back and do the rest of the stuff that you left off on yesterday. Okay? Yes, Brendan.
It's kind of like this, so, say if that, y-intercept was -2 instead of -1.
Okay, yeah.
How
Can
would
happen.
you draw that?
Alright, let me show you, just 1 second, and I'll show you the graph here, okay? that. Anyways, okay. So here's a graph here. X squared plus 4. And I want to take the reciprocal of that graph. That was really big. Okay. So what's the vertex here? 0 and 4. Sorry, I'm going to expand this. I need this to be big, 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 big.
That's right.
No, I'm going to have to do this. Okay, so 0 and 4 is my vertex. Which way does it open? Up. So it's going to look something like this. So that's all I need for that. I don't need anything else. Okay, now g of x. This will answer your question, Brandon. G of x is 1 over x squared plus 4. So focusing on the vertex for a second. 0 and 4 is your vertex. If I take 1 over the y value, it becomes 0 and what? What is it, Rex? No. What's the y value? Yes. The y value is 4, so when I take 1 over it, I get what? A quarter. So that's right here, right? So that becomes 0 and 1 quarter. Fair enough? This value right here would be 5. So, what's 0 over 5? Sorry, what's 1 over 5? Fifth. So this, all of these guys are going to get smaller and approach there, and approach right here. That's what your graph's going to look like.
So you can.
So, is there a vertical asymptote here?
No.
No. Is there a horizontal asymptote? Yes, there is. Okay? You are taking 1 over the y values. I don't know why it doesn't make that much sense, but you're taking 1 over the y value. So if the y value is 5 and you take 1 over it, it becomes a fifth. If the y value is 10 and you take 1 over it, the y value is a tenth. So they got to get smaller and smaller and smaller. As these values get bigger, your fractions get smaller. 1 over 100 is 100th. 1 over 1,000 is 1,000th. They're getting smaller. They're getting smaller. As you get closer to infinity, they're going to get smaller and smaller, but never hit 0. So this is the graph of 1 over x squared plus 4. Alright? So that can change. The only way the horizontal guy moves is if you had something like this where you had it outside of the actual x value. And I don't know if we do that, but that's the only way it would, this value would move, this horizontal axis would ever move on this question, is if you had it out here. Okay, so I don't know if we do that. We do it in grade 12, but I don't think we do it here. Alright? Okay, I'm going to shut the camera off and then I'll answer any questions from 7.2 and 7.3 that you were working on yesterday.